Yeah, hi. Good evening, everyone. This is the week 6 or 5. Uh, my first question is, how was the quiz exam? Can anyone share your experience, feedback, difficulty level for the questions?
So the C programming course questions were easy,
Okay,
but in other courses there were some lengthy questions.
okay. Other subjects are you are saying heavy.
Yeah.
Okay, okay, fine. Other experience, math is moderate. Okay.
The overall paper was not that difficult. It was pretty nice, but maths was really a typical level.
Math was difficult. Okay, okay. And what about the ESTC?
That was
So,
also like
so there were
at a
two
good level.
questions in ESTC regarding mesh analysis, and those two were lengthy.
Okay, Landy. Okay, because we checked some score graph, so we found that the ESTC is the worst, and then math, then C, and then English. So yeah, this is the same experience. So that means, according to you, math was the toughest, correct?
Right.
Okay.
Sir, today I can like yeah,
Mhm.
I can in the portal. Can I end my timed assignment? Like,
Yeah,
will
yeah.
I
You
be
you
able
can
to?
you can join and you can attend. Okay,
Because
so.
I have already written, I have in the when the timed assignment was first introduced, I
Hmm.
took all the screenshots of all the questions. Now I don't know will all those questions will repeat or not.
Questions will remain same. So
So,
yeah, so for
so
the first time assignment this
yesterday,
week.
I already in the internet compiler I already solved all those questions,
Okay.
but I forgot to submit those questions. Uh,
Oh,
so I today I will submit those.
okay,
Is
okay,
it
nice.
okay?
Yeah, that's fine. Because the questions are same, that you can, if you are saved some question in the previous day, that will be reflect today also. Okay, so there is no loss.
Thank you,
So
sir.
every week this new timed assignment will be open. So this is now timed assignment 1. Next week you will get timed assignment 2. So where the questions will come from the week 5 concepts. Okay, so like this we will release total 6 timed assignment continuously now. Okay, so just attend all these. So this is also for the practice for the OPP exam basically. So try to solve all 4 question in the given one slot at least. So only 2 hours. Just increase your speed accordingly. So just try to solve all. Then you will be able to solve the OPP questions in the given duration that time. Okay, so this is the main purpose of this timed assignment, and these assignments also contain the weightage in overall score, that 15% weightage. So that is also important. Okay, and like you have also practice assignments, but practice assignment doesn't have any weightage, that are actually only for practice purpose. So that we generally discuss also in the live sessions, but also practice on those, because this is programming course. You should know uh, how to write code. So that is the main purpose of this course, and the exam purpose is also same. Because of that programming exam we are taking for this course, not theory. Okay, so yeah.
Sir, whether the WTA will
Yes,
be
sir.
extended for one day?
So the actually plan is, we will release every week 3 days. So this time we have already released now. This today is the fourth day. So we have started this from Saturday, Sunday, Monday, Tuesday. Now we are thinking that due to quiz, we will also release this tomorrow also. Okay, we will extend one more day. Okay, only for this timed
Thank
assignment 1.
thank you, sir.
No, yeah. After that
Thank you, sir.
after that time assignment 2, then we will release only 3 days. Okay, so this we are releasing only because of this quiz.
Good afternoon, sir.
Yeah, good afternoon, Sonali.
Sir, but We received the message of only the today is the last day.
No, we have also sent the announcement on the portal many days before. You, I think, didn't check. Maybe we have sent the message. We have also posted on the group and many days before. Yesterday, I think, yes, yesterday we sent the reminder Monday. Okay, so still you have today, and maybe we will also release the tomorrow. So you have 2 days. So these are actually 4 programming problems, and that are not too much difficult. You can attempt and you can complete. If you have done all that week 4 assignment by your own, week 3 assignment by your own, then definitely you can solve maybe in less than 2 hours. Okay, so try to complete today and tomorrow. Yeah, Hemant.
Sir, could you please discuss one example each for like switch and nested loop and
Hmm.
continue go to, because
Okay,
I am
so
feeling some
did
difficulty in
you
understanding.
join the last that revision session on Friday, which we conducted? That I think nested loop I have discussed, and in the fourth week also I have discussed this nested loop. What's your
No,
doubt
sorry.
actually? You can directly ask the doubt, because today we have the
Yes.
plan to discuss week 5, because you have the deadline 14th for week 5 and 17th for week 6. That means you
Okay,
have
okay,
to
sir. You
complete.
may discuss Week 5, sir.
Okay, but you can ask a specific doubt, or you can also watch the previous recordings, and
Okay,
then
okay,
if you have any doubt, then you can ask.
okay, sir. Thank you, sir.
Okay.
But sir, the book recommended, na the book the recommended
Hmm.
C
So
programming.
that actually,
I think
yeah, that.
examples are not there, na?
So that books are actually recommended, but I don't think that you need to learn that book, because all the contents
What's
we are
that?
you. I don't think you need to learn that book. We are not using any questions from that book. There are lots of resource for the C programming available. Okay, so C programming is not a some unique course. That is actually very popular course, and that is lots of resource available on the net. So you can follow any resource, and we are also trying to covering all the things. Or we have also released this notes. Uh, I think you know that week 1 we have released the summary notes for the week, all weeks till 5. Have you checked that?
Sir, on discourse, no, sir.
Not discourse, that summary notes, PDF notes we have released on the portal. You are not aware? So inside the supplementary content, these week by summary notes we have released, na?
Yes, yes, yes.
Yes.
Some
So
notes,
you
summary
can,
notes is there.
so you can check these notes also for the to understand this control statement, where we have discussed this loop, and we have also mentioned the by the graph, that by diagram, how this functionality actually happens. You can see this all loop, if conditional statement, switch case. You can understand that how the flow actually happens in this type syntax. Okay, so just try to look this document and just check. After that, if you have any doubt in these topics, then we will cover. Okay.
Okay, sir. Okay.
Nested loop is also there.
Excuse me, sir.
Yes.
Sir, I also have a doubt, although it's from week 4, but can you please clear that?
Week 4, you have doubt. Okay, so what topic?
Yeah. Sir, actually, I have confusion between two things, that break and continue statements that we put in if function. If
Oh,
statement.
break and continue. You have confusion. Okay.
Yeah.
Okay, so that's fine. Yeah, so Has, yeah, I'll cover this today. So Has, K, you have raised the hand. Okay.
Yes, sir.
So,
Regarding
So can you hear me now?
continue.
now I can hear you. Yeah.
Yeah.
Please go ahead.
So So I have a small doubt, like the books which were recommended aren't available online. Is there any method to get them?
I think we have already released the link that you can download that book.
Go to Zleaf.
No, that actually one drive link on the forum. Okay, you are that qualified student or term
Yeah,
student?
yes, sir. Qualify.
Okay, so it is not available on the portal. Okay, so let me check one second.
Yes, sir.
So we have the link directly. Okay. Okay, understand. Reference. Let me put direct access. Oh, link is not there. Or course space. Okay, so books link is not there. Okay, let me check on the drive. Then one second. Supplement. It's not. Books of C. Okay. So this one drive. Okay, let me share this. I'm sharing the link in chat. Okay, so all three books is there in this. Okay, you can check these.
Okay, sir. Thank you.
Yeah. Okay, so let's. Okay, so Mihir. Yeah, Mihir, go ahead.
Sir, actually, I just saw the answer key, and
Hmm.
in the folder of Drive where the answer key is posted,
Hmm.
there are three files which are uploaded: QEF 3, 4, and 5.
Hmm.
Now, I don't remember which one was my paper. So, is there any way to confirm, or will I? I have to just cross check by opening.
Actually, for qualifier student, we have used only one QP, I think. So you will find out the only one question paper in all three. To just check if the ID and all the questions are same in all three. They may be only from the different the timing or slots, but QP was same for the qualifier.
I was the quiz student, so even for me it's
Okay,
same.
you are that term student.
Yeah.
Okay, then QP is also same. Yeah, one QP we have used for the that.
Sir,
Okay.
where can I see the response?
I
My,
think
I
it
mean,
is
my recorded response.
so that sheet maybe you will get in your dashboard. So yeah, answer key you can see it is released on the portal. You can see
Yeah,
this
I got the
answer key
answer key,
exam. Huh.
but my recorded response was not there.
But you can remember only 16 questions are there. I think you can remember. But some I think some answer sheet is also released. I'm not sure how that released actually. So maybe just wait for some time. So maybe you will get. Otherwise, you can just verify your answer based or your memory base. Okay.
Okay.
And sir, the feedback form is only if I spot an error, right?
Yes. If you have any doubt, like any question is wrong, any answer is not
But
correct, you
even
have
if I
to.
choose no error, then I have to write something there.
How so you can fill this form, but this basically this form is for if any discrepancy is there, if any doubt you have in any question, like this question is not correct, this answer is not correct. Like if you have any doubt and you are sure about that, then you can fill that feedback.
And sir, one last thing, the answer key has no deadline, right? It is here now uh, till the results are out, right? It will not go away, right?
No, that answer key will not go away, but yes, for feedback form you have some limited time and maybe just fill this as soon as possible if you have any doubt. Okay, so maybe
Okay.
by tomorrow the result will compile. for the qualifier. I'm talking about the qualifier. Actually, we are just trying to complete this qualifier first. After that, we will complete term.
Okay, okay.
Okay, so if you have any doubt in quiz paper, then you can fill this as soon as possible.
Okay, got it. Thank you.
Okay, yeah. Okay. So regarding this loop break statement, so let me just open the compiler and show you what is the meaning of this break and things. Okay, so basically this break statement is used to stop the loop that execution. So like let me
Sir,
yes.
I want to suggest something.
Mm-hmm.
Like in the previous 3 days, there because the time programming assignment was not in the calendar, I forgot to upload my solutions in the website. So what my suggestion is, because our time programming assignment is from 8 to 10, so the classes should be shifted to 8 to 10, and there is a math class from 8 to 10. So it should be shifted in the evening session.
One thing actually, what this week what happened actually, we generally release this timed assignment only for Saturday, Sunday, and Monday. Okay, and on these days, I think there is no class in the evening. That it
Yeah, but we
yeah,
had a
but yeah,
qualifier, right?
so for qualified students, what you can do, you can just try to complete this on today or maybe tomorrow. We will also release tomorrow this. Okay, so this is just an extension for the qualified students only. Okay, because of that we have extended this, but timing is the problem. Yeah, we cannot move any other timing because we have that live session on the every day for any courses, many courses actually. So if we shift this of any other timing, definitely the other course live session will be there. So we cannot shift any. We don't have
No, like
actually.
I was suggesting that when we have this C programming class,
Hmm.
at that time we should also have the time programming assignment. Like the class will remind us that there is a time programming assignment.
Okay, so that means we should schedule a calendar event for that,
Yeah, yeah, yeah,
like this.
yeah.
Okay, yeah, that we can do. We can just add into the calendar, so you will get the notification for this. But we generally actually releasing announcement continuously. We are releasing announcement on the mail, on the forum, and for every time assignment we are releasing this announcement. But yeah, this is good suggestion. Definitely we can add this into the calendar all 3 days. So that will be the good. Yeah, yeah, that we will follow. Okay, so from next time assignment we will schedule in the calendar. So okay, that will, but that event will okay, so that event means this is only timed assignment, there is no meeting.
Yeah.
Okay, 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 yeah, yeah, we will follow this. Okay, so yeah, regarding this break and for continue things, so let me just take one example. I think that will be good to understand. So I am running a loop here, so like for loop, so for and int I'm taking one variable int I equal to like 1. Okay, this is the initial point. We are starting from this I from 1, and we are taking one condition, this I is less than equal to 10. Okay, and then I plus plus. Okay, so this loop is running from 1 to 10. Okay, both are included, 1 or 10. And inside this we are printing something. Okay, so we are printing, and we are also checking that one condition. Let me check if I is even. Okay, so if I is even, so like I is divided by 2 is equal to 0. So that means now I is even. So what we will do, we will print this I inside this. So print f and percent ld, not a, or yeah, okay. So and I value. Okay, and slash n we will take. So this is print statement. So that means we will print this I, if I is equal even, then we will print I. Otherwise, we will not print anything. So this is just a simple loop. This is running like, and we will get this 2, 4, 6, 8, and this 10. But what we can do, we can also add some condition like this. We want to just find out the even number before 5. Okay, so before 5 we want to print the even number. So we will take one more condition here, and we will check that if I uh, I is divided by 5, okay, and that is equal to 0. And inside this, what we will do, so this loop is running. Actually all these things are inside the loop. I is starting from 1. We will this loop will run I 1 2 3 4 5 like this. But this is the first condition, and this is the second condition we are using, and we want to stop this loop before completion of all iterations. So we have the value for I equal to 1 to 10. So that means if we don't uh, uh, okay, so by default this loop is running for all value of 1 to 10, but we want to break this loop in between without completing of all iteration based on any condition. Okay, so let's if we found any number which is divisible by 5, then we will stop this loop. Okay, so what we can do, we can use this break statement.
Sir, please run this command without break, sir. Let's see what happens.
So without break, so this will run as the previous output. You can see this is running fine, so nothing is happening. Actually, if I is divisible by 5, so there's nothing statement is in the block, so that means it is not affecting the output. Fine.
Yes, sir.
Okay, or we can also make this easy. So let's we are not writing this condition. Okay, so we are printing like all value of I. So you can see we are getting this 1 2 3 4 5 6 7 9 9 10 all value. But we want to check that when we found any value which is divisible by 5, okay, that first value, then we will stop the loop. So based on the condition, we can put this break statement. So what will happen? This loop will run fine. Okay, it will print 1 2 3 4. But once it value comes as a I equal to 5, then this condition will become true, and this break statement will execute. And this break statement is actually terminate the loop without checking this condition. So this is the condition given for the termination by default in the loop, but we can also terminate with the help of this break statement before that condition. Okay, so once this condition you found true, then you can break the loop, and that means your control will come out to this loop. So suppose if any print statement you are using here, so that your loop will directly jump to that statement. So like um, so come that out of loop. Okay, so let's run this code. Now you can see, yeah, because we are using this print statement before the break. Okay, so that means 5 is also printing. Okay, so now loop is running, I equal to 1, condition is not satisfied, then I equal to 1 printed. Now 2 will be printed, 3 will be printed, 4 will be printed, and then 5 will print first, and then this condition will become true, and this loop will be terminated by this break statement. Okay, and that means next iteration will not run, loop will terminate by this break statement at this point. So after that, this your control is now coming out to this loop, that print statement will execute this outer one. Okay, you can see this. Okay, so this is the purpose of break loop, and you can also use here, this is a for loop, same things you can also use the while loop. Inside the while loop, suppose if you are using like this while condition, so while I is less than equal to 10 or less than equal to 10. Okay, and this is the while loop, and inside this we have to declare this int I equal to like 1. Okay, so this is the similar code to the previous one, and we have also increment this I inside the loop, so that means I plus plus. So now this loop is running, and we don't know, we have started this loop, and once we found the first number which is divisible by 5, the loop will terminate. Okay, so that by this break statement, now you can see the same output for this also. Okay, so you can also break the while loop with this help break statement. And another thing is, suppose if you have two nested loop. So let me run one nested loop now. So yeah, we found that we gave one question based on the nested loop, but most of the students actually marked the incorrect answer for that. So like for int that code I am writing. Okay, so that question I think that I'll remember fine. So I equal to
Sir, the
j.
nested loop didn't have any option. Like we have to write
That
numerical
how many
question.
times hello print that hello C will be printed like this. Yeah, so we found
Loop
only
means
9.
what, sir? Nested loop means what?
So loop inside the another loop, that is called as a nested loop. Same things if is that a conditional statement, if a statement is comes under the another if statement, that is called as a nested if else. Okay, so nested means when the any statements comes into the inside the another statement. So that was, I remember that this I is less than equal to 6 and I plus plus. Okay, so I am not sure the exact code, but I'm writing that. Okay, so for int j equal to that 5. Okay, and j is greater than equal to uh, that not greater than equal to, yeah, equal to 1, or j plus, sorry, minus minus. Okay, so this is actually nested loop, and I'm printing here printf like hello C. Okay, and still SN. So there was one hello C is inside the loop, and there is one outside the loop. Okay, so I think this was the question. So 0 to 6, and this was dot greater than. Okay, so this was, I think, this one. 0, 1, okay. So okay, so this was the code. Let's run this. So you can see we are getting this number of hello C, and after that this statement is printing. So let's remove this. So maybe some syntax is different. I'm not sure the exact one, but we found that most of the students mark this as a wrong answer. So we discuss this how this nested loop is actually works. Okay, so loop understanding should be there for the OPP exam. And also one more thing, OPP exam we have the syllabus till week 7. Okay, so just try to complete all the things before this OPP1 exam till week 7. So let's do one note.
Sir, what is QEF 2, 3, and 4?
QEF means where it is given?
It's in the, wait a minute. In the qualifier exam answer key.
So these are some code for the qualifier exam.
Like
QEF.
all the questions are different.
So all the questions are different
Means the questions in QEF2 is different in QEF3 and
no C programming. Just check the C programming paper.
yeah, I
Actually,
am checking the C programming.
that contains all 4 papers actually. Okay, so regarding this nested loop, let's discuss how it actually execute. Okay, so here 2 statements are there. First is this is a print statement, and another is this print statement. Okay, so now the outer loop is running. Okay, so outer loop is running. That means I value is running. I value is running from 0. Okay, so what is the range for this? 0 to 6. Okay, so 0, 1, 2, 3, 4, 5, 6. So this is the range. So that means 0, 1, 2, 3, 4, 5, 6. All value will come in this range. And now you can see when we are running this loop. So for I equal to 0, so this is the initial value of the I. When I equal to 0, and this means this condition is true. Now your execution will enter inside the loop. Now this is a nested loop, and this loop will run completely for single value of I. So that means for 0 value, your J loop will run from where? So 5. Okay, so this is, yeah, in the exam paper I remember that this was the I, sorry, not the 1. Okay, so this was
Excuse
the
me, sir.
hmm?
So this is the question of qualifier exam.
A similar question actually we asked. This is not the exact one. Maybe some value are changed. I'm
Yes,
not
sir,
sure.
because it is not equals to less than or equals to 6. It's only the I is less than 6.
Okay, okay, okay. Thanks for remembering. Or and this is okay. Lower one.
Yes, sir.
Okay.
Yes,
So
sir.
that means this is not coming in the range. Okay, yeah, that's fine. Okay. So so this is not coming. So 0 to 5 range is there. So now for 0 I, when I equal to 0, we are entering inside the loop because this condition is true. Now J loop will run from where? So 5. Now I am writing this side. Okay, so 5 to so I'm writing or value. Okay, so 5 4 3, because this is a decreasing loop. Every time we are decreasing the value, and this value will move till greater than I. So what is the I value currently? 0. So that means it will run 5 4 3 2 1, that number of times. Okay, I think this is equal to, if I correctly
So
remember,
this
so
is j greater than equal to I.
equal to, no, yeah, okay, so yeah, so if equal to is there, then 0 will also come. Okay, so this is fine. Now this is the first iteration. That means how many value we have? 5 4 3 2 1 0. So total value 6. 6 times this internal print statement will perform. After that, this loop will stop, and next iteration will come this print statement. That means plus 1. Okay, so that numbers means 7, total 7 times hello C will be printed for I equal to 0 only. Okay, now move to the next. When after that, this I will increment it and I will become 1. So that means this side. So J value will start from same 5, but this time I is now 1. So that loop will run for this 5 4 3 2 1 only. Okay, so 0 will not come because this is greater than equal to, and I now become 1. So this time is 5 times it is run J loops. In this internal print hello statement will perform, and plus 1, this additional one. Okay, so plus 1. So that means 6. Next, this J loop will run 5 4 3 2. It will stop at 2 because this is the value. J is greater than equal to I. So I is now 2. So it will run from 5 to 2. So, and that means 4 plus 1. So this is now 5. Okay, so in this way, next 3, it will run 5 4 3. So total is 4. So that means 3 plus 1 4. Next fourth value, it will become 5 4, and this means 2 times and plus 1 outer. So this is total 3. And next 5 times, so this is uh, only 5. Okay, and after that, that means 1 plus 1 2. Okay, so now if you add this, so 7 plus 6 13, 18, 22, 25, 20, 27. So total sum is 27. So in this way, this loop is running nestedly. Okay, so for each single value of I, the internal part completely execute actually first, then it will move to the next iteration. So output should be the 27 for that question. But we found that only 9% student actually marked this correct. Okay, so this question was the difficult one question actually in the qualifier exam.
Sir, please explain the last option, that is when I equal to 5.
I equal to this one, this last iteration.
5.
So I equal to 5. So that means what condition this will be? So J equal to 5, and now J is less than equal to. So just replace this I with 5. Okay. Okay. So now this is become a condition for internal loop. So when J is now 5, now this condition is true for this. Okay. So j is less than equal to 5. Yeah, that means 5 is equal to 5. Yeah, this condition is true. You will enter inside the loop. Only one time you will print this internal hello C. After that, j will become 4. At that time, okay, so this is, sorry, greater than equal to. After that, it will become a j equal to 4, and this condition will become a false. Internal condition will become a false. At that time, your loop will terminate after one printing, and then this is the outer one. So this will print every time for the this loop. So because of that, one time the internal print will perform, and one is the outer print. So total 2 hello print will be performed for when the I become 5. Okay, so now this is a nested loop, and this is the solution for this question. Okay, so this was that QP question. So let's discuss this break thing. Okay, so I wanted to discuss actually break thing. Suppose if we have this loop like this, so j is less than equal to 5, okay, and j plus plus. So I'm writing any other code. Outer j loop. And this is inner j loop. Okay, so or just print a that j value. Or what we can do, we can just check the condition now, and we want to stop this loop for if our I that we found that if j is not divisible by 2. Okay, so every time we can break this. So if j is percentile 2 is equal to 0. So now that we want to break this. So now how this break will actually work here. So now this is a nested loop. Okay, so we always check that where actually break is actually put in the code, and which loop is the closest loop for this. Okay, so break is used here inside this inner loop. So this inner loop, which is we are using for the j, that is actually the closure loop for the break statement. So when this break statement will come, this will terminate the closure loop, which actually where this break is actually exists. So now you can see when we run this. So how many times you are getting this out of j loop statement? Because every time when you enter this I equal to 1, okay, so now this loop will run fine in internal loop. But second, or we can also print this I, so you will also get this j value. So print f and percentile d, and just use the j. Okay, so you can see here. So let's run. You can see at what time this loop is breaked actually. So you can see for j equal to 1, now j become 2, and then this loop is terminated, and this statement is now executed. Okay, so out of j loop. Again, you entered again for the next value of I when I become 2. So sorry, I become 1 in the next iteration. So same things again happen. So j equal to 1, then find j equal to 2 is printing. Then when the j become 2, this condition become true, and this break statement is performed. Then again this internal loop will terminate. That internal loop will break by this break statement. Okay, and this is the use for break statement. And what is the use of continue statement? So let's use the continue statement now. So I'm writing continue here. So continue means okay, what, let's see, I'm writing this print. I'm using this time this print statement after this. Okay, okay, so just see this inner loop. So this continue statement, how this will work. So here from when j equal to become 1, okay, so this condition is not true, then this 1 will be printed here. Okay, now when j become 2, so this condition is now true, and continue means without executing the that next instruction which are coming after this in this loop, that will not execute. You will directly jump back to the next iteration after this when you found this continue statement. So that means from continue, when the continue will execute, you will directly jump to the next iteration without executing the remaining part of the code which are coming inside this statement. Okay, so when you run this, you can see 1. Okay, so 1 you are getting printed in the output. After that, you are seeing that 2 is coming, but 2 is not printing by this print statement. Why this is not printing? Because you have used this continue statement, and your execution is directly jump to from that position to the next iteration without printing this statement. Okay, now this j become 3, so again this is now printed. Okay, now next j become 4, same things, you found this j4 is divisible by 2, you are getting this continue statement, and again the next statement will skip and your iteration will move to the next. Then this loop is now completed, so 1 to 4, and you are only printing odd value, so 1 or 3 in the every times. So continue means you want to jump to the next iteration without executing the remaining part of the code which are coming on that block of the loop or anything. Okay, you can directly jump back to the next iteration. So that is the purpose of continue. Okay, it is clear? So
Sir,
you can,
5 not come, sir. 5 less than, na?
or let's make clear, this is not a nested loop. Now you can see what will be the output for this. So let me just make this 10. Okay, and I am also removing this. Not this. Let me print this. Percentile t and value of I. Now, and this is I. So this is the easiest example for this. We only want to print the odd number for this. Okay, here we are checking the condition. If the number is even, then we are using this continue statement. Continue means do not move forward to the next statement, directly back to the next iteration. So if number is even, this instruction will execute and you will directly jump to the next instruction without executing this print statement. Okay, so you can see 13579 is printing. So let's listen, we are using that this will come separately 13579. Okay, so this continue is actually stopping the execution when it's executed actually. Okay, yeah, so this is the purpose of continue statement. Break actually stops the complete loops. It actually pass to the next iteration without executing the remaining instruction. Okay, so this is clear that continue or break in the loops.
Here, return 0, sir. Please explain, sir.
This return 0.
Yes, sir.
So this return 0 is basically true for the operating system. This actually, yeah, in Week-5 we will just look this return things. But for when we are using this return 0 inside the main function, so we are writing this main function return type value is integer. So this is actually a function, and function we can return the some value to the same code. So that type actually we define here. So but for main function, this is the main function for the any C program. So we need to return any value for from this main function, and that value is just a information for to the operating system. That means your code is executed perfectly fine without any system error like this. Okay, so 0 means your program is executed successfully. Okay, so this is the meaning for to the operating system. So this 0 is actually written to the operating system, so that the operating system understand that everything executed successfully.
Sir, there may be 1, 2 also, na, or only 1?
You can also use the 1, but that 1 have some meaning for the operating system, like some error. some error code 1 2 3, but 0 represents some successfully execution. Okay, so this is for only this main function. Otherwise, when we write the our own function definition, so we can return any value. So let's that we discuss in the week 5 content. So anything is remaining in week 4 to discuss. So actually, I planning to discuss the week 5 today. That we will discuss what is this return and what is the use of this. Okay, but here for the main function, return 0 means that program is successfully completed. That information will be passed to the operating system. Okay, so any doubt in week 4, or we can move to the week 5?
Week 5, sir.
Okay, fine. So let's move to the week 5. So last actually session I have discussed little bit, but in between we have stopped to this qualifier things. Yeah. So I'm just recapping again this function things. So what is actually function? Function is just a block of the code that we can define, and we can give some name that function, and that is actually defined for some specific purpose. So what we can do, if we are planning to write any code for any problems, and where we need to uh, perform any specific task many times, we can say that many times or again and again, okay, more than one times we want to perform some specific task. So what we can do, instead of writing the code multiple times, so same set of code writing multiple times, what we can do, we will write only one time inside a block, and we will give one name for that block, and we will use that we will call that block when we actually required in our program. So I'll give one example to explain that. So how we can use the one block of the code multiple times in our program. So the function is just a block that is written for some specific task. Uh, okay, and these are some that features of the function. So why we use this function? So the reusability. So that means we will write the code one time, and we will use that code multiple times without writing the code again. And modularity, break down complex program into smaller manageable units. So also we can break our, suppose if you are writing the code and your code functionality is very large, and that means you need to write 1000 lines for the code, and you are continuously writing the code without any break or without any comment or anything, so that code will not be readable for others. Okay, suppose if you give that code to the others, okay, just this is the solution for that code problem. So other cannot be understand that thousand of lines, so they cannot just manage how this flow is executing, how the logic is performed in the 1000 lines, so they cannot understand. So what you can do, you can break the functionality into the blocks. Okay, and that you can define blocks separately in your code, and you can just give the name of each block according to the working of that block. Okay, so if you write your code in that way, so that code actually is more understandable to the others, or as well as you also. Suppose if you look that code after maybe 1 month or 2 months, you cannot also understand your code if you are writing the code in without this block forms, or you are writing the 1000 line continuously. So that actually breaks the complex program into a smaller manageable unit, and you can also understand your code if the code is written like this in the block pattern. Readability, it increase the readability of the code. Maintainability also. Okay, so that suppose yeah, you are you are performing some addition task, okay, in your code, and that addition task is or we can take any other example. If you are performing any specific task, and that specific task is performed like 50 times in your code, and you have written that code 50 times separately. Okay, if you have written your code 50 times separately, suppose later you find out that there is some error in your that specific task code, then you have to change that code at the 50 that locations in your file. Okay, because you have written separately each time. But what we can do, if we write the function, okay, function or block of the code, and we call that code from every times when we want to use, So if you want to change something in your code, so you need to just update in only your one block. That will reflect into the each call. So this is the benefits of the function. And so these are some category of the function. Standard library functions we have. You know that we have used these function many times. So like this standard library means that is defined by the language itself. So here some function like this printf, scanf, these function we are using continuously, okay, from the first program. So printf means we are displaying something in the output console. Scanf means we are reading something from output console. So that are input output based function, and we use this function. We directly write this printf and we just perform the task. Okay, we directly write this scanf and we perform the task. But internally, these function have some coding. That's some set of instructions. So that is defined inside another file, okay, and you are only just calling this function by the name, okay. That is defined in another file that is called as a library, and we include that library in our code, and we directly use these function without writing the complete code for that. So this stdio.h, this is just a library, or we can say that this is a separate C file where all function is defined, all instructions, that code is written already. So that file actually we include inside your code, inside our code, and we directly use their function which is already defined inside this library. So that is called as a standard library function, which is already defined by the language. Then external library function is also there. So some that not comes under the language, but these are developed by external source, okay, and these are also available. You can also use this, you can include these library, and you can also use the direct function from that library, okay. So like this math.h. So if someone is writing many code for mathematical problems, so there are many things you need to calculate during the math problem, like sine value, square root value, power value, cos value, log value. So like this, so these all these related math concept related function is defined in this library, and you can directly call this library and you can perform your task, okay. So just call this sine and pass the value and you get the result output for this, okay. So this is called as a external library function. And after that, so these function are already defined. Now you can also write your function, and that is called as a user defined function, okay. So if you are writing something, if you're writing any code solution for any problem, you can also define your function and you can call that function in your code anytime. So like this addition that we will okay, discuss this by the example. So this user defined function, declaration and definition, these are the two terms actually we use, declaration and definition. So declaration means we will just provide a prototype, and that means what is the name, what will be the name of the function, what will be the return type of the function, what will be the input parameter, name and type of for the function. So that actually we will just declare, okay, for the compiler. So compiler will understand that, so there is one function with with this name, this return type, this input parameter type. So this is for the compiler purpose. So compiler will understand that there is a function with this name in the file. So this is called as a declaration. This is just a prototype, or we can say this is just a structure definition of the code. Okay, so this is called as a declaration of the code. So you can see this is the way to declare the code. You have to write a function name, okay. So function name also contain the same variable name, that rule. You cannot use any specific symbol for that. You can give any name, but you should follow the variable rule which you have already learned. So what the value, how we can define the variable name. So same way you can also give any name for the function according to your task, what you are doing inside the function, okay. So this is the function name you need to write. After that you need to put this open bracket and close bracket, okay. So this is just a identification of the function. You need to put this open and close brackets. Sometimes you can leave these internal things based on your requirement. Sometimes it is not required, so you can leave this empty. inside the open and close brackets, but this open and close bracket is are required for the function definition. And this is the return type. So that means when you are writing the function, after that function you will write some instruction set inside the function, and after execution of these instruction, you want to return something from the function or not. So that you have to define here. So what type of data you want to return from the function, and that return means that the data will be returned to the same code at the running time. Okay, not the output. We are not printing something here. Okay, this is different from the print statement. Return means we will return some data into the same code at the runtime. Print statement means that data is printing into the output console. So we will take some example to understand this. So return type, we will define what type of data we want to return from the code. If we don't want to return anything, so we will use a return type void. Okay, so we will write void here. So that means no, we will not return anything. So this is a syntax for to declare the function prototype. And without writing this function prototype, you can directly define the function. Okay, so at the time of defining, you can also write the same things, that function declaration and as well as the definition at the same time you can do. So same things, if you want to define means you have to write the complete code for the function. That means you have to write all the instruction for the code function. Okay, so return type, you have to define that function name, parameters. If you want to pass any parameter to the function, so you have to define that, and then you have to write the instruction inside this block. Okay, so this is the body. This is called as a body. This open curly brackets and this close curly brackets. After writing the function name, you have to use this open and close. That is called as a body of function. So what you are writing inside this open and close bracket, that is the body of function. So that body will execute when you will call this function. So this is the syntax for the definition. So let's take some example now on the portal. That here. Okay. So let's take some easy example to understand this. So what I'm doing here, so I'm taking some printing statement function. So what we can do, we can define the function. So in C, if we don't want to return anything from the function, so we will use the return data type void. So void, okay, and like display hello C. Okay, so I'm giving any name. Okay, so I'm giving the name like display hello C, or we can like this hello C. Okay, and this is just a name of the function. You can give any name, and after this open bracket and close bracket, this is the identification, and after that we will use this open curly brackets and close curly brackets, and we will just use the print statement inside this. So print f, and inside this hello C. So now this is a function. You can see this is a similar to this main. You can see the similar type of structure. Here the type of return is integer. Here we are returning type of integer. That type of the data is void. Void means nothing. Okay, no data, missing data. That means, so when we use this nothing, that means we don't want to return anything from the function. Here we have declared int, so because of that we are using this return statement. We can also write the void here. Okay, so then there's no need to return this 0 statement. Okay, so now this is a function definition as well as the declaration. So this is also same things we are doing. We are also declaring as well as we are defining. So that means we have write the function definition. Now from the main function, because the compiler always execute the main function instructions. So what we will do, let's use the slash.
Sir, here declaration is what, and definition
Declaration
is
means we have declared all the things, so like void, name, and if we are suppose if we are want to use any parameter, so we will all declare like this int parameter 1, int parameter 2, like this. So declaration means we are declaring all the input parameter, return type, function name. We are telling to the compiler. Another way is, so this is the one way, and what we can do, we can define this function anywhere in the file, but we can declare at the top of the our file at the program like this. We can declare, so like void and display, and there's nothing, so we will just write like this. Okay, so here we have just declare, okay, and later we have defined, we have mentioned the definition for this function. So definition means the complete set of instructions or body, that is called as a definition. But here we have just declared to the compiler, so when the compiler will execute the instruction, so like this instruction will execute first, now the second instruction will execute. Okay, so now this actually there's no error comes if this what happened. Suppose, let me just give the make comment here. Okay, and when we are writing this function after the main function, okay, so compiler actually pre-process this and compiler execute this line and then directly jump to the main function. So now the our current compiler actually handle this. It will not give any error. If suppose if I call this function from inside the main function, it will perfect fine. It will run fine. Okay, so like this. Okay, now calling this, and okay, some error is there. So okay, display. What is this error? Okay. Display hello see void. Okay, let me see to clear this. Is there any mistake? Hello see. This is so. Right, like this. Okay, so 1 second. So Control X, and if I define here, okay, here it is working. So let me again do the same thing. Hello C, and if I declare here. Okay, yeah, it is working. So what happened, if suppose we are declaring this function after the main function in our file. Okay, so this is a C file, and we are declaring this function at after the main function at any position. So there may be a multiple function defined in our code. So at the time when compiler execute this, so this compiler will execute this file, and after that it will jump to the main function, and compiler will try to call this function. Okay, so hello C. So compiler is calling this function, but till now this function is not identified by the compiler. Okay, because this is coming after the main function. So compiler don't know what is this at this time. So because of that, compiler is giving error. Previously implicit declaration is like this, something conflict type hello C, void hello C. So this error is coming, but what we can do, we can tell to the compiler that there is one function which we have defined later, okay, in the file. So but we have now tell to the compiler that there is a function where the return type is void, the function name is this, and there's no parameter. Okay, so now this is a declaration for the compiler. So the compiler will understand that there is one function which is defined in some place in the file after the main function. So compiler will not give any error for this execution. So compiler, when you run this code, that compiler will work fine. Okay, what you can do without writing this here, you can declare this function, define this function before the main function. Okay, so that will also work fine. Now this will work like as a declaration as well as the definition. Okay, both we have done at the same time. Okay, before the main function. So this is a declaration as well as the definition. But the previous example was the declaration is separately and definition is separate. the code. So here you can see now the function things. So what we are doing, we have defined one function, and this function is just printing something, okay, inside the thing. So because of that, this function is not returning to the code anything. Because of that, we have used this void. This is printing something, okay. And from main function, we are calling this function. And now how many times you want to call this depends on you. So we have write that code only one time, and we can call this multiple times, 5 times suppose we are calling, okay. So how the execution happens, so once the compiler controls comes to the first call, the calls means your execution will move to this function, and this part will execute, okay. This function body will execute. So this printf hello c will print. After that, your control will move back to the same call here. Then next instruction will come. Okay, so this is again a call. So that means your control will move to the call, that function definition, and the statement will execute again. Okay, so in this way, after execution this complete body, your control will move back to the same call where it is called. Okay, so now if you run this, you will get the 5 times that hello c. Okay.
Sir,
Hmm.
sir, in this case, sir, first hello option not executed, no?
Yeah,
Initially,
this is a comment. Now
no,
this is
no,
a comment. Yes.
no, no. After void hello,
Hmm.
uh, in the braces written printf hello c. Okay, is
Yeah,
that printed?
this will not be printed without calling. Without calling, this will not be printed. Let's just make this without no call. Okay. Now this will not be printed. Nothing is coming out. Okay. So that means this is just a definition, and compiler will start execution from here, main function. Okay. If you are calling this function from the main function, that function will execute. Okay, without calling, that function will not execute. Only the compiler will identify that there is one definition, some function, that function is defined only. So compiler will understand that one function is defined. At any point, if this function is called, then function that body will be executed.
So can you write any other thing in printf function in void function?
That here.
Yes, sir.
So other things means what you want? What do you want?
Within the printf function, like other than hello, like if you write only C, so how will the function be called? Only by hello C, or we have to write C
No, print.
in main?
This is a print statement. What you are printing inside this print statement, that is actually printing. This is just a name of the function. Okay, so now if we run this, so C is printing. When we are calling this function, our control is jumping to the function body, and this statement is executing. Okay, so yeah, this is a simple function where we are not returning anything. Okay, so we are only using the print statement. Let's just use some return statement. So how this return things actually used. So I am writing one function which is actually more generic. So that add function. Okay, so we want to perform some addition, and we want to call the addition addition operation by the function. So that means we want to add some integer value, and we want to return the result in the form of integer. So we have some like two integer values. So int a comma b. Okay, so we are taking this, and we are reading the value for this ab. Okay, so scanf, or we can just explain first and then we call it later. And we want to perform the addition for a and b. So we are reading some value like a equal to 10 and b equal to 20, and we want to perform the addition operation, and we want to store the result in result. Okay, so int and s. Okay, so int s equal to a plus b. First thing we can do like this. Okay, so a plus b. Okay, and we can print the result. So printf, that's the sum is like %d, and what is the value of s? So this is s. Okay, so this is a function. We have not calling that above function. We are getting the answer correct. Okay, so let's how we can do by this as a function. So what we can do, we can make a function for this. So like add, and we want to read some value from this function. So that means we want to take some input for that function, and we can give any variable name. Okay, so this variable is just defined. So like int x comma int y. Okay, so these are some variable for the function. Okay, and inside the function we will perform addition. So like int z equal to x plus y. Okay, now we want to return this z result to the main function. Okay, so like what type of data we want to return? So integer. So that we will write here integer data type, and now we will use the return statement. So return z. Okay, so now this is the function definition. Here in the definition we have declared that we will use x variable, which is integer data type, y variable integer data type. Initially internally we have used z variable, which is also a integer data type, and we will call this function. At the time of calling this function, what we will do, we will use this name function add. Okay, and add we will pass comma a comma b. Okay, now you can see we are passing a comma b. So that means what is passing here? So here value is passing. Okay, so what is the value of a and what is the value of b? This a equal to 10 and b equal to 20. 10 and 20 will pass to the function, and the 10 will be stored inside the x, and b 20 value will be stored inside the y. Okay, so this x and y are the variable for the function. Okay, here a and b are the variable for main function. Okay, x and y are the variable for add function. So these variables are totally separate variable, and these have also the separate memory, not the same memory. So when we are passing the value, so a, and when we are writing a comma b, so that means value of a and b will be passed to this function, and that value will be stored at the location of x. A value will be stored at the location x, b value will be stored at the location y. After that we will use that value by the x and y name. Okay, so x and y. Okay, and that addition will perform, and that result will store at the z location, and that return z, that z value we are returning from the function. So that means this function will be replaced by the return value of this function. Okay, so what we have written here, so that means if we are returning something from the function, that we have to store some somewhere in our main code where from we are calling that function. Okay, so that means when we are calling this add a comma b, so at the place when this function will execute, after execution this function will return a value, so that value will replace this call. Okay, so that means if we are passing 10 and 20, so 10 20 will pass to the function, 10 plus 20 will perform here, 30 will you will get inside the z, and that z value will return by this function, and this function call will be replaced by 30, this z value. So that expression will become a s equal to 30. Okay, now you are getting s equal to 30 and you are printing s here. So when you call this, you can see you are getting the same answer. The sum is 30. So let's explain this in the notepad more clearly, so you will get clear idea. Yeah, if you have any query, please ask.
Sir, after going the values of a and b into the values x and y, z will be calculated as x plus y, and the z value will be returned to what, sir?
Z value will be returned to the call. Okay, so actually this return is happens in the same code when the execution is happening at the runtime. So what happening, this instruction will execute first. Okay, so this is execute first. Now a is defined, so a and b is declared, so that means a is pointing to some memory block and b is pointing to another memory block. Okay, so now you are storing a equal to 10 and b equal to 20. Okay, now this instruction when you have finding that int s equal to add, and when you're passing this a comma b means this value are passing, so 10 comma 20 value are passed to this function. That means this is the call. So we are calling the function. When we are calling the function, so these two value will be passed to the function. So this is one. So that means this function will execute. And inside this function, the one value is coming for this x, which is actually a 10. And one value is coming for y, this is a 20 when we are calling this function. So this x and y are the local variable for the function itself. Okay, only add function. So you cannot call this x variable from this main function. This is the outer. Actually, this scope, you don't have scope inside the main function for this x. You cannot print x value from here. Okay, so inside the main function. So this is called as a scope. We will discuss this thing also. Okay, so here when this value are coming, so this x and y have the separate variable for this add function. This is local for add function. Okay, so that means x have some memory block and y have some memory block. Okay, this is separately from a and b. Now when we are calling this, so this 10 value is stored now for inside the x, and y is stored inside the here. Okay, so and similarly z is also a separate memory block. Okay, where you are storing the result of x plus y. So 10 plus 20 is 30. Now you are returning this z value 30. That will be returned. So when that means you are calling from here. So this call is coming at this point, and this function is returning something. So that return value will replace this call by the value. Okay, so this z value what you are returning by the function, so that will be replaced here. Okay, so that 30 you are returning, so 30 will be replaced by this call. Okay, now this you can see this expression become int s equal to 30. Okay, instead of this call name, this function is now returning something, so that return value will replace this call. So now s equal to 30, so that means 30 is now assigned to s. So some s memory you have for the main function, so that 30 will be stored at this position, and then you are printing the value of s. So you will get the answer 30. So this is the print statement which we are using the main function, that is actually printing the output in console. Okay, so now in this way you can call this function any number of time. Each time that x, y, this memory will be allocated separately. If suppose if you are calling 2 times this function, so this x and y and z, these three variable will become totally separate. Okay, so for the first function, this memory allocation will be happen separately, and second function again this x, y, z will be performed separately. Okay, this x second call will not be the same as that variable will not be the same as the first call. Okay, so this is just like as a copy. We are just making a copy of the function and executing of this. Okay, then we are making another copy of the function and executing this by this call. So in this way the execution happen. And suppose we call this function multiple times, you can see suppose we want to perform multiple addition operation inside this function. So now I am removing this instruction and I'll just use this inside the directly print statement. You can see, so printf, and we want to write like this, percentile d, and we can directly call from here. So okay, so add, and we can pass this, so like 2 comma 3, 2 comma 4. Okay, so inside this we can call this function any number of times. I'm sorry. Okay, now I'm removing this and this variable. So 1 and 4, like 5 and 4 or 3. Okay, so you can see now we are calling this function 3 times. So what happened actually when we call this function inside the print statement, so this is also a expression type. So we are calling this function, we are passing 2 and 4, 2 and 4 will be passed to x and y, that x, y, this operation will perform, this function will return something, that value will be come here at this point, and that value will be printed by this print statement. Okay, so 2 plus 4, that 6 will return and it will replace by here 6. Same things, 1 plus 4, 5 will replace here. So in this way you can print. Okay, so let's slash n. Now you can see 6, 5, 11. Now you have defined this function only one time, and you can call this function any number of times when you want to use. Okay, so sometimes this is very small example. Sometimes if you are writing some specific task, so like if you want to perform a prime number checking, okay, so you want to test the prime number checking, that number is a prime or not. Okay, so how you can do this? You can define a separate function to check the prime number, and you can call that function any number of time from main function or anywhere. Okay, so you can also call the function from any other function, so that is also fine. Suppose there is a problem like you want to print that all numbers which are coming from 1 to 100 which are prime. Okay, so here you need to check each number from 1 to 100, the number is a prime or not. Okay, so there is a way you can write the code, that prime number checking code, multiple times in your logic or other things. What you can do, you can just define that number is even or not. Okay, so let me just check that how many, that print all the number which are divisible by 3. Okay, so let's write the code for this. Okay, for some specific range. So like I'm giving some name like check. Okay, so check, and we will check that we are reading some value for this. So let's I'm taking one value int x. Okay, and we will check that if number is that divisible by 3, then we will return true, otherwise we will return false. So here we will return, so we will check one condition inside here, and like if our x value, okay, so x is divisible by 3 equal to 0. So for true we can return like 1. Okay, so return 1 from this function, otherwise else we can return that 0. Okay, so this is the function check int x. We will check this number is divisible by 3 or not, and inside that, suppose if any range is given, any two range we have, and we want to check how many elements we have which are divisible by 3 for any specific range. Okay, so like return 0, this is the last statement, and before that, suppose we have int, this is the starting point. Okay, so suppose s equal to 1, and we have endpoint, so like int e equal to 100. So in between we want to find out that how many numbers are we have that is, which is divisible by that 3. Okay, so let takes one count, so int count, and that count we will start from 0. Okay, and what we can do, we can run a loop. So for I, for int I, and I is equal to s. Okay, this is the starting point, and when I is less than equal to e, this is the end point, and I plus plus, and every time inside the this loop we can call the function. So if the check of I, okay, is equal to 1, okay, then we will increment our count. Count plus plus. Okay, and so this is the condition, and we will just print this statement, this count value in the after that. So print %LD comma count. So here, now this is the code. We are giving some range value as 1 to 100. We can pass any range. So this loop will run according to the given range, and after that we will call this function. So check I. So this is the function call at this point, and this is the function call. We are passing the I value. That I value will be replaced, stored inside the x, and inside this function we are checking that if this number is divisible by 3, then we are returning 1. 1 means true. Okay, that means divisible by 3. Otherwise, we will return 0. Okay, so this is the type of int. So that value, return value, will be replaced at this point. Okay, so if your function is returning 1, so this place, this check I will be replaced by 1. So 1 is equal to 1, true. Okay, now your count will increment. So that means how many times you are calling this function total? That 100 times. So 1 to 100 times. So 100 times you are calling this function, but this function is already defined one time in your file. Okay, and this is executing 100 times. So no need to write this function code line 100 times separately. You can just define one time and you can call any number of times that will execute. So when you run this, you can see you're getting the result. The result is 33 numbers which are divisible by 3. Okay, so in this way you can write a separate function for a specific task. If you feel that in your problem statement you want to execute some specific task many number of times, okay, so instead of writing that code separately every time, so just you can define a separate function for that. Okay, and call that function when you require in your main function. So like this. Okay, so this is the main, this is the function things. Okay, this is called as a parameters. So you can define any number of parameters, so which you feel that what type of value you will receive in the function. So just declare that as a input parameter. So here you can see we are passing this integer I value. Okay, so that I value, because of that we have declared some receiver parameter. So this is we can also understand by the receiver that receiver variable. So this variable actually will receive a value, and that by the help of this variable we will use our computation. Okay, and scope is totally separate, so you cannot access this x value. You cannot print this x variable here. You cannot write like this x. Okay, so you can see the you are getting error, undeclared identifier. Okay, and same things, you cannot access any variable here. You cannot write like directly that I value. Okay, because I is not defined. So here this is count. So here you cannot access I because I is declared here. So this is the local variable for main function. Okay, you cannot access this from outside of the main function. So because of that, we use this input parameter and we read the value, and that value we used for the computation. Okay, so any query in this function definition, declaration example, any query till now? So now from Week-5 onwards, you will write this function definition in your problems, programming problems. Okay, so let's check some problem that I click this problem. Okay, so you can see to complete the code. Yeah, so this is a recursive function fact. Okay, let's this is another thing this I'll also discussed. Yeah, you can see write a recursive function. This is also recursive. Okay, yeah, prime product. You can see write a function prime product. Okay, here the problem statement is asking to write a function, not complete code. Okay, so just write a definition of this function. Here it is already given that write a function that accept a positive integer. So that means one variable you have to define a int m, like, okay, as a input, and return 1 if m is a prime product and 0 otherwise. What is prime product? It is given here. Okay, definition of prime product is given. So that function definition you need to write. According to that problem statement, you need to return a statement. So return 1, okay, and 0. So that means you return some integer value. So just take a return type integer and write the function definition. So here you can see inside this main function, this ever function is calling. So if prime product m is equal to 1, so that means your function should return 1 correctly. So that will come here, and that this print statement will execute. Okay, so this is the main function, and from main function we are calling that prime product, and you need to define that that prime product function according to the problem statement. So this type of problem you will find out in the upcoming weeks, or from this week 5 onwards. So just practice on this, that function things. Okay, any query till now?
So this C programming is total weeks 12, na? With 12 weeks, na? Or 11 weeks,
Yeah,
sir?
we have 12 weeks. That like we have only content for 11 weeks. So no content in 12th week. Okay,
Okay.
that is actually just a free week. Okay, so yeah, this is the things, and let's move to the next. So I have discussed all these things. So this is just a one image. So this is the example of add integer a. This is a function declaration. Okay, and this lower one is the definition. So you can see here we have declared the function, that is, but define, this is the definition of function. And function definition means we have defined all the body instructions. That is function definition, function body with statement, return statement. If we want to return something, so that return, we will use this keyword return, and we will return this value. Okay, so and according to this return statement, we have to also declare this return type. Okay, suppose if you miss this and you're returning something, you will get error. So just follow this all rule of the syntax and accordingly write your code. So this is a function declaration, this is definition, and this is a call. We can just write a name and use the bracket and pass the value, what value we want to pass. So this is just a call. Okay, and this call actually passing the value to the function, and after that you are getting some return, and that will replace this call. Okay, and that value will be assigned to this result. So in this way you can call the function and you will get the output. So all this is the terminology for this function. Yeah, so different ways to pass parameters to the function. So pass parameter to the function, we have already seen this call by value. We can also pass the value call by reference. That means we can pass the address of the location instead of just writing a direct value or variable name. What we can do, we can pass a address. So that means how you can access the location. So that address, this thing is discussed in week 6, pointer. Okay, so pointer things. So let me just quickly give one example how we can read the value from main function variable to that function. Okay, so I'm taking another example here. So like void display. Okay, and here we will declare one pointer. So okay, so this is a pointer, and pointer means that a variable which actually stores the address of the memory, not the value. It store the memory locations. Memory locations means address of the variable. So that means we will use one pointer. So like ptr I am writing, so ptr, and what type of pointer we are taking, so that we will discuss later. Okay, so I'm just giving one small example here. So that means this pointer is actually storing the address of integer variable. Okay, so now this, and inside this function we will just display the value of that location. Okay, so that we will use this print statement, printf and percentile d, and this is the that stick ptr. So when we use this value as here, so this will display the value at this memory location. So wait, what is why this? What we missed? It is giving error. So can you see where we missed this bracket? Open bracket, close bracket.
Sir, semicolon after the function.
Oh, okay. Yeah, thanks. Okay, so this is the definition. So now suppose let's I am writing this int a equal to 20. Okay, so now we are calling this function. So display. This time I am passing the address of this a. So how we read the address of variable? We use this AND symbol. which you have already used is inside the scanf. So and a. Okay. Now this means we are giving the address of this a to the parameters. That address will store inside this pointer ptr, and we are reading the value of this location. Okay, so this is not a value here. Okay, this is a reference. We are passing a reference. We are passing a address of the variable at that memory location. Or we can also do something. So we will update this location value in from the function. So let's update this value like star ptr and equal to or plus equal to 5. Okay, now this. Okay, now we are changing that memory location. We will see that the updation is reflecting inside the main function or not after this function call. Okay, so we will print this a again. So print f and that percentile c, percentile d, and the value is a. Okay, in the previous examples we have seen that we cannot access the variable from other functions, but this time we are passing the address, memory address. At that memory location we will change the value, and that means the memory is same which we are passing. If we are changing something on the memory location, so that will also reflect to the main function. So here if we run this, okay, so let's use a /n, and I'll use this print statement before and after. Okay, okay, so now you can see I'm only using the print statement inside the main function. So what happening, this is the first print statement. We are getting 20 for the value a. After calling this function, so the reference memory address is passed to this pointer ptr. At that pointer value we are updating. That means we are updating the memory locations, and we are increasing the value by 5. Or we are not returning anything by this function. Okay, so that memory updation is will also reflect in from our main function. We have updated the memory location. So you can see we are getting 20 and 25. So this is called as a call by reference. So we can pass the address of any memory. Okay, so the previous example was call by value. So call by value, we are passing the value of the any variable. Okay, here we are passing the address of any variable. So these are the two ways to call by how we call the functions. So call by value and call by reference. So that we have discussed already. Call by reference. So this pointer concept we will again discussed in the week 6 concept. Okay, so this week we will discuss. Okay, in the next session. So now this is the all about the function. Now the another concept is recursion. So recursion is also another important concept in the programming. And what is this? Recursion means we repeatedly call the same function, or we can say that we call the same function from the same, or we can say that if any function call itself. Yeah, this is the correct definition. If any function call itself. So here you know that what is the call and what is the function. Okay, suppose if I'm writing a function, so like if I'm writing a function like int or suppose void. So void, the function name is abc. Okay, and this is the function, and here we have writing some body instructions. Okay, so now this is a function and this is the body of this function, and we are calling this function from main function. So we have int main, and we are calling this function abc from here. Okay, so this is the another things we have already discussed. So we are define this function, we are calling this function from another function, main function, and this will execute. What happen if we are writing a function? So we void abc, and this function, same function, will call from the inside of this function. So suppose we have written some instruction, and after writing some instruction, we are calling this function from the same function like this. Okay, so like this call, we are calling the same function abc from the function body itself. So this is called as a recursion. Okay, when function call itself. And this is the one way, direct recursion. Another way is indirect recursion. Suppose if you have two functions, void, and this is a function. Inside this, you are calling the b function, and you have another function, so void b, and inside that function, you are calling the a function. Okay, so this is also again when you will enter inside this b is called now b, and you are coming here, and the a is called again. You will come here, then you will call this b like this. So this will run like this.
Sir,
Okay.
sir, here we have to give break, na, because it will run infinite time.
So that is the next thing. So here you can see in this example, this is a direct recursion example. This is an indirect recursion example. But how this will stop actually? If we are writing this recursion, this type of code, and we are not using any termination things or logic things, so that will run infinitely. Okay, so that will call again and again like this. So because of that, there are two things inside the recursive function. One is base case, and second is recursive case. Inside the recursive function, so when we have this type of function, when the function call itself, that function is called recursive function. Okay, and for the that recursive function inside the body, these two case should be there. One is base case. Base case is called as a terminate case. Okay, so terminate case. And this recursive case is a when we call the same function again. Okay, so recursive call part. Call. When we are performing recursive call. So this is called as a recursive case. And this is a base case. If at any time we will find this base case true, then we will stop the process and we will not call again. So this is the main properties of the recursive function. You should have base case for the recursive function, otherwise your code will not stop. So
Sir, I think the code will stop. Like the stack memory will get full and the OS will
that is
interrupt.
another way. So that is the limitation of the compiler. If your compiler actually will understand that this that this call is actually happen lots of time, so that compiler will stop. Okay, but logically that is not stopping by your any logic in your code. Okay, that compiler is actually stopping that because it is consuming lots of memory. Every time when you are calling the new
Like
function,
in infinite loop, the compiler or the operating system doesn't interrupt. But in this case, the operating system will interrupt
it will
because
interrupt because it is consuming memory. Every
yeah.
time when the new that recursive calls happen, one new stack memory is allocated. That memory is allocated if this is continuously infinitely running. Because of that, operating system is stopping this after some fixed number of times. So that is actually fixed, depends on the compiler. So Python have some limit like 2000, and C have some limit. Okay, so after that number of times it call, that it will compiler will actually stop that. So that is called as a recursive that error, or we can say that some recursive depth error. Okay, so how this actually works? So now this is the base case and recursive case. So base case is called as a terminate case. So we write our code in that way. So after some iteration, that recursive call, our this base condition should be fulfilled. Okay, then our code will terminate. Okay, so I'll give one example by writing the code. So how we can write the recursive code. So I'll call this function. So I'm writing any random function. So return 0. This is the line. Okay, so I'm calling one function. So like recursive print, recursive print. Okay, so this is a function call. And from this function, okay, let's I pass some value. So how many times we want to print? Okay, so we will print something. We are passing initially 10. So 10 times you want to print some hello C or hello world, anything. So let's define the function. So recursive function. So df, this is a Python syntax. Okay, so void recursive print. Okay, so this is the name, and here we are reading some value int like n. Okay. So now from this body, so let's write this. Now we will write the recursive function, and we will call the same function again. And this is the call, int n. So this is the call from inside. Okay, but okay, let's again same thing. Okay, so now if we are writing the code in this way, so that means we are passing 10 value, and this will call again, this will call again, so this will code will give some that error. So let's check this, what code is giving error. It is giving any or not. Our code is not stopping. Okay, you can see some error is coming on the CPU limited, RAM limited. Okay, above top. Okay, so let's stop this. How we can stop this? So yeah, this is actually running on the cloud. Because of that, this hanged. The applet hanged actually. Refresh this page. Okay, you can see we are getting this type of error because here the memory is consumed a lot. So because of this infinite things. Okay, so that should be the more important things
Sir,
here.
Sir, here in the main function, sir, whenever call occurs, that is recursive print, the value 10 will be assigned to value assigned to n. Okay.
Yes.
After that, recursive print n means recursive print in the bracket n means here 10, na?
10 again. This is the same function. Value is passed. Recursive print 10. 10 will again assign to new function. So here actually every time new memory is allocated for the n. So this n is totally separate every time. So that means this 10 value will be passed to the each time. Okay. So let me open one C tutor, so that will be the more actually you can understand. So Python tutor. No, not this one. Python tutor. Visualize. Okay, so C. Okay, so I think this is the good compiler to understand this C recursive call. Okay, so here actually in this function we got the error. So our program is actually that hanged. So what we can do, we can write a base case. So how we can define the base case? So like we can give the condition if this and or we can do what we can do if we have this recursive one thing. And okay, so if n is equal to, so like we can give the example, if n is equal to that 1, okay, or 0, okay, then we will just write something. Okay, so what we find? Okay, so return n minus 1 g plus n. Okay, or we can define this stuff. Okay.
Sir, n less than equal to 2.
So I wanted to print something. So print f. Actually, I wanted to print this n value. So that %d, comma n. Okay. And all this n minus. Yeah. So this is -1, and here. Okay. So we will take this inside the else condition. So else. Okay. Now you can see what will happen next. Okay, so we can write something here. So like or we can skip this, or we can take the condition if n does not equal to that, or n is that greater than equal to 0. then we will use this recursive case, control X, and remove this. Okay, so now you can see in this code what we are doing. When we are calling this function, initially we pass the 10 value, but inside the recursive function, you can see we are reducing the value every time. So, okay, so this n minus 1 we are passing in the next recursive call. Why we are passing? Because we are taking this condition as a terminate condition. If our n is greater than equal to 0, so this part will execute. At any point, if our n becomes 0, or n, sorry, not 0, or we can take greater than. Yeah, if any time if our n becomes 0, we will stop this. Okay, this means this condition will not be satisfied, and this part will execute without the next recursive call. Okay, so when this condition is not satisfied, so when we are writing a recursive function, recursive call, so just define this recursive call in this way. So every time your recursive call should be come closer to the terminate condition. Okay, if you have defined any terminate condition, your recursive call input should be come to that terminate condition after some false. Okay, so here we cannot take like plus sign. Okay, when if you are taking plus sign, so that means our initial 10 value will become 11, 12, 13 like this. Okay, and it will continuously run till the end of the integer range. So here our condition is if we reached at the 0, so that we will not run this part and we will skip this, and that will be the terminate point for this. So at that position, so suppose if I use this -1, so that means initially our n value will be 10, and when we enter inside this function, this 10 will be print, and when we are calling the next time this function, we are passing n-1, so that means 9. Okay, so that means 9 will be passed to this n, and again 9 is greater than 0, so this 9 will be printed, and next time this will become 9 minus 1, 8. So in this way this will run, and after 10 calls this condition will break, and that our that calls will stop. So when we run this, you can see we are getting this range, so /n. So let's see, we are getting this 10, 9, 8, and after that this 10 times call, recursive call, this is stopped. Okay, and you can see how the memory is allocated every time. So for just run this code in this compiler, so that C compiler, and see the visualization for this. So every time new memory is allocated. So now stop, run this step by steps. So let's you can see when we are calling this from main function, so 10 times. Okay, so n is now become 10. You can see this is the first stack. You can see this is stack is a type of memory which is allocated for the each function separately, and heap is also a one type of memory that you will discuss. I think Week-5 it is discussed in some lecture, or maybe Week-6. So that is actually store some global memory which is used in the program. Or this is for the local for each function, and this is for the global memory allocation. So here next, when you can see we are using this print statement. Output screen is coming 10. After that, next recursive call will called. You can see another block is created. So this is the next iteration. In this block, you can see you are getting n equal to 9 at this place. So this is separate memory location compared to the previous memory location. Okay, so that this is.
Sir,
So,
sir, can you show the memory address of recursive print? Then it will get clear.
So that you can also do.
Like inside recursive print, if I print the address.
Okay. That or we can also print the in the same line. Okay. So what you can do here before this, we will write this control percentile, and we pass this p. We can write, okay. And here we will use this end. Okay.
No, sir, not address of n, but address of recursive print.
So this is n actually. This is which is the recursive n?
The function address.
No,
The address of the function in the stack. That is what I am trying to say.
Okay, let's run this. Let's maybe.
So here percentage p means, sir?
that p means it's print address actually. So let's see. You can see we are getting this. Oh, what we are getting now? Okay, sorry, we have used the different. So this is actually percent, and this is n. So now we are printing. You can see we are getting this address. Okay, sir. Okay, this is for the first 10. When we are running the next time, we are getting another. You can see BAC, which is this different one. So this n is now created separately for this every time when we are calling this function separately. So this n is now the different memory location. Okay, now value, you can see what value we are receiving. So value in the next time you are receiving 8. Okay, at this time this will be another memory location. Okay, so this memory is created inside the stack memory. So every for each call, for each function call, this memory is separate stack is created, that memory is allocated. Okay, for the n.
Sir,
Yes.
sir, what happens after it goes to 1, sir? Please explain. N equal to 1 when it
So n equal to, when n becomes 0, so this condition become false. At this time this recursive part is not executed, and that is the terminate point. If you're not executing this, so all code is now stopped, complete.
So it will not go again to main function, na?
It will go to the main function if anything. So this is the call actually here. So when this is running, after that it will come back to this location, first call. So this is the starting point. You will come back after the completion of the recursive part. So that is like print hello. If you're printing something, print f, so that will execute after the all iteration. Okay, so like this statement is written here inside the main function. So when we are calling this here, so this is jumping to this function. Now this jumping function is a recursive function. It will execute into that like a nested call
Up to n becomes 0.
and become 0. And after completion of all these recursive calls, you will come back to the same pointer here, and then this line will execute, print hello. Okay, so in this way this will execute. So let's run this. Like suppose if we complete this, you can see every time this function is now getting less input. Okay, and once this is become a 3, okay, let's move this. So now n become 2, n become 1 in the next. Okay, so this is fine. Still you can see you entered inside the print statement. So that means one more print statement will perform. So this one. Okay, now after that, when you call next time, so you will move to this here, and here now you can see what value you are getting. So now n equal to 0. Okay, the last recursive call. Now this condition is not true. You will directly come out. Okay, and you will come back to the main function from here. So like okay, so yeah, this is the recursive thing. So this is a recursive call. You jump back to back. That will I'll also explain this. So this is why this is running here, because this is jumping back to the previous location. You can see this is now moving back. All locations are done. Now you are coming at this location. So what happening actually when the first function is called, so that function is called, so like I'm writing the function name abc. So abc, this function is passed with 10. Inside this function we have calling the that function, we are printing something, and we are calling the abc9. Okay, this function. So that means new call is happened, and that new copy of the function is run. So this means 9 is coming here, and again this is not a terminate condition, so recursive call will happen. So abc8, so this is the jump, and from this location, so next call will happen. So abc and 8, and this is the next. Okay, so this function will run, and after that recursive call abc7, like this. Okay, so in this way this will run continuously till last value, terminate condition. So that is actually abc like this is 1, and inside this that function call is abc 0, and from that point you are passing abc 0, that is n actually, and here this is the terminate condition. When n becomes 0, so you will terminate. Okay, and this is a void
Sir,
function.
can you share the code in paste bin?
Where?
Paste bin. Like you have just to paste and share the link in the chat.
Okay, this code.
Yeah, this code.
Please place next.
Okay, where is the shared link?
Pastebin.com. You go there and paste the code and share the link.
I'm not putting. So,
Like it
that
is a
is
website
okay. It is a
called
website.
Pastebin. Yeah, pastebin.com.
Pastewin.com. I never used
Yeah,
this
paste.
one.
Yeah, just paste the code and upload it and share the link.
This code you are asking.
Yeah.
A sec. Where here?
Here, yes.
Okay.
And scroll down. There is a upload option. You create new paste here.
This one.
Yeah. And now copy the link from the above URL.
Uh,
URL.
this one.
Yeah, and give it in the chat.
Okay. So I never use this one. Okay, so I'll just discuss this quickly. I hope you have sessions. I think na math one session.
Yeah.
Okay, so let's quickly finish this. So okay, so here I am explaining that how this actually happens. So this is the call things. So A B is I am writing one more ABC 2 before this. So that is ABC 1. Okay, 1. So this is now there is a chance maybe before calling this recursive call, maybe there is some instruction written here. Okay, after this call. So what happened when this last terminate condition is done? Okay, so that means here nothing, there's no recursive call. So pointer jump back to the previous call where this call is actually happens. So if any statement is remaining after this, so that will perform. If it is not there, so that means this will be completed at this point, and you will come back to the previous call like this. Okay, so this is the first call, but after completion of this part, you will come back to the same call point. So in this way you will come back. So because of that, that code is finishing now. If any print statement or any statement is written after that, then that will execute after this recursive call. Okay, so in this way you will come back at this point, you will come back at this point. If anything is remaining, all will execute. Now this main call will consider as a complete execution. So in this way this call process is actually happens in the recursive function. So because of that, this code is running like this. Okay, so after reaching at the last stage, it is moving back to the each pointer position. So this is called as a recursive function. You can try some basic function. I think time is done, so we will ask to another TA or another instructor to discuss in more detail in the next session. So okay, so now this is a recursive. Just read this document also. Some example is given. Just try to execute this factorial example. Okay, and just try to imagine it. Okay, just how the execution is happening. Or you can also use this tutor, Python tutor or C tutor, that to understand how the call is actually happening. Okay.
Excuse me, sir.
Yes.
Sir, if we are not applying the condition, then we should write the break. If we are applying the condition, we should not write the break. I am right?
Here you want to stop this process using break. You are saying that recursive things.
Yes, sir. Yes, sir. If I am not applying the condition, then we should write the break.
How you can decide the break? Actually, that break will also consider as a terminate condition. Okay, so what is the meaning of terminate condition means here? We will not call the recursive function again. This is the main meaning here of the terminate condition. Okay, so every time when we are entering inside the function, we are calling the same function again. But at any point, if we will not call this function, then that condition will be considered as a terminate condition. How
Sir,
you are stopping
in
this?
recursive function, how come we write break? Break is used in loops. In recursive function, we have to write return.
So that because of that, instead of break, you can use the return statement or like this. But break is not a good here actually.
Okay, sir.
Okay, yeah, break you can use inside the loop if you are using some loop inside this function, and from the loop you are using this recursive call. That in that case you can terminate the loop without calling the recursive function again using the break statement like this. Okay, but here you can just write your logic in that way. So at any point after some call, some specific condition, you will not call this recursive function again.
Sir,
Okay.
if in this example, if we print break, the answer will be same, because without break it
No, here actually
it's
inside
the
the
one
if
only one
statement,
time only it will run, na?
no, inside the if statement there is no break actually purpose. Where you want to write the break? Here.
Yes.
So this is
Because
the
it's already running only single time, na?
first thing. This is giving a error. We cannot use the break statement in the without the loop or switch statement. So this break is only allowed only for the loop and the switch statement, not the conditional statement. Okay. So this is a basic example, or we can also understand this by the that sum of, like we can take on more realistic example, like if that addition of or that factorial. Okay, so factorial is the very popular example for this. Okay. So for factorial, if we are getting n, n is equal to 0, then we will return 1. Okay, else we will call the same function again by calling the previous value. So we will return n into, and I'm writing the function name fact that n minus 1. Okay, now we will understand this. So let's change this function name to fact. Okay, and we will pass some return value int. Okay, and here we will read this int z equal to that fact call. So fact. Okay, and I'm passing 5 values this time. So this way, so like this is return. Yeah, this is also example, and let's print this z value. So print f percentile d, and this is a that z value. Okay, so z. So let's run this, and then we will understand this. So you are getting the factorial answer for 5. So 5 into 4 into 3 into 2 into 1. In this way we are getting. So let's understand this, how this is working actually. So inside the main function, we are calling this fact 5. So this is the first call, fact 5. Okay, and this is the first call. We are printing here the output, and we are reading some that z equal to fact 5. Okay, so z, and we will print this, print z here. So this is the first call, and inside this first call we are calling this fact 5, and inside this function we have written one terminate condition. You can see this, if n equal to 0, then we will return 1. Otherwise, if n is not equal to 0, then we will return n into fact this. So this line is a expression. From this, we are calling the same function again. So how this is working? So initially this is not fulfilling the terminate condition. So that means we are returning a return n. So what is value of n? 5. 5 into n minus fact n minus 1. So fact n minus 1 means 4. Now this is a new call. So that means new function is started. It's fact 4. Okay. Inside this function, again the terminate condition is not satisfied because this is not equal to 0. So same, return 4 into that fact 3. Okay. Now this is a new call, fact 3. Okay. Inside this, return 3 into fact 2. Okay, this is new call, fact 2 inside this return 2 into fact 1. Okay, again the new call, so fact 1, and then again return 1 into fact 0. Okay, now this is an again new call, and here this is the terminate condition, so fact 0. Now you will satisfy the terminate condition now and become a 0, so you will directly return 1 here. Okay, so according to the condition, so return 1. So what happening now, you can see last statement is returning 1, return 1. So this means this call will be replaced by the 1. Okay, now 1 into 1 become 1, so this expression is now become completed. So return 1, that means fact 1, this function will return a 1 value, and that will be replaced here, so that will become a 1. So 1 into 2, 2. Okay, so this function will return a 2 value, which will be replaced here, 2. 3 into 2. Okay, 3 into 2, 6. So that this function will return a 6 value here. Okay, so that 6 will be replaced here. Now 6 into 4, 24. So 24 will be returned here, so this is 24. And now this 24 into 5, 120, and this function, this 120 will be returned to the main call, this one, and this is 120. Okay, now this is assigned to z, and z we are printing. So in this way this factorial function is working. Okay, when we are calling this, so now this is a terminate condition, we are not calling this function again, otherwise we are calling this function again. So n into fact n minus 1, so this will call like this, and you will get the factorial answer. Okay, and same things you can also get the sum of first and natural number like this, just use this plus, and you will get the that 5 plus 4 plus we're getting correct. Okay, so this is correct, sorry, this is 0 now. Yeah, so in this way, if you want to find out the sum of first n natural number, so that 1 2 3 4 5, if you pass this 10, you will get 55. So you can see 55, only this change. Okay, so now this is a recursive call. So this recursive way of writing the code actually helpful for some complex problems. Okay, so that actually we can write a solution for some complex problem is with very easy code if we understand this recursive.
Sir,
Hmm.
I am not getting any timed assignment in my dashboard.
Oh, it is not released?
No.
Yes, sir. I am facing the same problem, sir.
Okay, can you refresh the page now?
Yeah, sir, got it now.
Okay, now so okay, so we will close today 15 minutes late. Okay, so 10:15 around 10:15 or 10:30.
Okay.
Okay, then okay, so we will discuss the remaining thing later. So this is the main part of the week 5 actually, this function recursion and scope. Yeah, one thing is pending, so we will discuss that in the next session. Okay, so also was the that week 6 lecture also. Okay, the deadline is 17. Okay, then just try to complete this time. Okay, then thanks everyone.
Thank you, sir.
Thank you, sir. Thank you.